Never guess it.
Storing files in the Walmart chip aisle. I want to use Matrix, but no one else uses it. I've gone into why I don't like Matrix many times. But yeah, network effect is definitely a big one. Honestly, my main reason for not using Matrix is it's just a nightmare to manage servers. That's honestly the main issue. So, anyway, that's a side topic. There have been a lot of these videos of like storing data in a YouTube video, or storing like a Arch ISO in a YouTube video, storing that in a YouTube video, all of this sort of stuff. I don't know how this one functions. I'm not entirely sure what the hell we're looking at here, but someone wanted me to look at this. This is an April Fool's video. I'm sure it's going to be very interesting, to say the least. Let's just see what this is.
You'd never guess it, but I've actually stored a file within this Walmart chip aisle. No, it's not stored on my phone, or a flash drive, or some other digital medium, but with the actual chip bags themselves. Yes, this idea is really dumb, but some really interesting math went into this. I went into this idea with one goal in mind: store the string "Hello World" within the chip aisle of Walmart, a phrase all programmers are far too familiar with. I'll cut to it right now. We store the file by either having a chip bag facing outward, representing a 0, or flipping it around, representing a 1.
This is stupid, but I don't see a reason why it wouldn't work. Assuming the bag actually has a distinct front and back.
It's really simple, but theoretically with enough chip aisles you'd be able to store any file you want. Since I wanted to physically do this, the string "Hello World" has 11 bytes, so 88 bits. I didn't want to flip around about 44 bags of chips.
Yeah, and then the staff come to me like, what the hell are you doing?
So let's compress it. This is where Huffman coding trees come into play. It's...
God, okay, we are, this is actually a real video. I thought this was just gonna be a joke, okay.
a lossless compression algorithm thought up by David A. Huffman. You see, he was a student at MIT in the 1950s, pursuing his doctorate. One of his professors offered a final exam, or an option to prove an algorithm for compressing data. Huffman was about to throw in the towel and submit to studying, but then it came to him. A compression algorithm dubbed Huffman coding. This is a tree-based compression algorithm which a compression algorithm dubbed Huffman coding. This is a tree-based
Yes, it is the Elden Ring tree.
compression algorithm which shortens the length of common bytes and increases the length of uncommon ones. For example, for storing plain text, we know E is the most common character.
I'm aware of like Huffman encoding. I actually hadn't bothered to look into how the algorithm functions.
So it will be stored as a 3-bit number, whereas a Z could be stored as a 16-bit number since it occurs very infrequently in text. The way we construct this tree is pretty simple.
Okay.
We count and store the frequency of each character. We then take the 2 least common characters, the ones with the lowest count, and connect them like so. We then take the sum of their frequencies and treat it as one node. We then repeat this, making one big tree in the process. When we finish with a big tree like this that has used every character we intend to compress, we treat each edge of the tree as a 1 or a 0. Then each character is represented by the path you traverse to get to it.
Oh, okay. Huh.
One extremely important aspect to note about this tree, and why it even works in the first place, is that the compressed version of a character cannot be the prefix for another, which is why characters do not have any children in the tree. For example...
Oh, I didn't even consider that. Okay, wait.
Which is why characters...
Okay, so everything has a unique... Okay. Everything is a unique path. There is no duplicated path. No duplicated subpaths. Huh.
Characters do not have any children in the tree. For example, if an E was a 1 and an A was a 1-1, and we were given the text 1-1-1-1, it could mean E.
Yeah, that's called Japanese. Wait, let me show the let me show the thing. Japanese with no kanji. Side tangent. We'll get back to the main video in a moment. But this is very important. Very, very important to the subset point. Let's jump ahead to the removed kanji version. It's actually very pretty handwriting. Yeah, I can't write that well. That basically demonstrates the point here in a very succinct form.
AA, EAE, AEE, or EEA. You could probably imagine when decrypting an entire file, this sort of ambiguity is going to lead to an impossible conversion.
Yeah.
Anyways, let's get back to the task at hand. Let's take the string hello world and construct a Huffman tree corresponding to it. Using this tree, we shorten the 88 bits of hello world, stored as normal computer plaintext, to 32 bits, meaning I'll have to flip about 16 bags of chips. A much more reasonable task than 44 bags.
Can't do maths.
So let's do it. The Walmart I go to is always super busy, so as to avoid looking like a complete lunatic, I went at 10:30, 30 minutes before closing to avoid...
I hate you. I genuinely hate you with my very being. I deal with people moving shit around every single time I'm there. If you actually do this in person... Oh my god, you actually go and do it in person. Oh my... The staff fucking hates you.
Avoid the most suspicion that I could. I also tried to hide my phone as well as I could, so as to not get asked to leave by staff for recording. Made it to Walmart. It's raining out, as you can tell. 10:30. Hopefully will not arouse any suspicion or get kicked out, so...
You're gonna do exactly that.
I'm a little nervous, but let's do it. We have officially infiltrated Walmarts, but we are hit by the worst case scenario possible. There is currently a worker restocking the chips.
Yeah, of course they are! It's 10:30 at night! They're fucking doing their job!
So, as to not look weird, I think I will wait a little bit till they're done.
They will not be done. They have many things to do.
The coast is clear, I'm gonna start.
Oh no.
I think I'm gonna go on this layer right here, since it has a lot of uninterrupted chips. So I'm gonna start. I've officially done it. I look so weird, but...
They don't have distinct backs. Doing this is just... Jesus Christ. I messed up a few... Wait, hold on. I actually messed up a few bits because I was nervous.
That is hello world.
I don't even... What
what
row was it? Wait, what row was it even on? I'm back. I'm not horny anymore. What did you go and do?
Is hello world.
It is, I think it's this one. We did start Non-Stop Nut November, so, you know.
I got one weird look. I definitely thought I was a weirdo, but...
You were a weirdo.
It's finished. Didn't get asked to leave. Let's go. Great success. It was a tremendous win. I successfully stored information within an aisle of Walmart. But how big of a file could I possibly store if I used every chip aisle of every single Walmart in America to store a file? So, I did the only reasonable
Such a fucking stupid video.
thing I could think of, counting exactly how many bags of chips were on the shelves of this aisle. I counted 128 bags of chips on a shelf, and there were 8 shelves. So
the Walmarts are not the same size.
1,024 bags of chips in the aisle. There are 4,618
He doesn't take that into consideration, does he?
Walmarts in America, and assuming all of them have the same size chip aisle,
They don't.
Yeah, they definitely don't.
that means we could store 128 bytes in any given Walmart. So we could get about 0.6 megabytes if we used every single bag of chips in every single chip aisle of every Walmart in America, or about 0.0004% of a Baldur's Gate 3 installation. Once again, the absolute enormity of our disks continues to amaze me. One idea I had to store an infinite amount of data would be to use a singular Pringles can. My idea is as follows. Rotate a can of Pringles an extremely precise amount, then record the percentage the can is rotated with respect to a full revolution. Then take the decimal and convert it to a binary number. Theoretically, if you could get any precision you wanted, you'd be able to store any file of any length with one can of Pringles. As you could probably guess, this video is just an April Fool's, but I hope it gave you some cool insight into the world of prefix trees.
I hate this video so much.
Really fun to make, and I felt super sneaky secretly recording in Walmart. It's not something I usually do. As to not give any extra work to a Walmart employee, when I successfully completed the task, I flipped back all around the chips.
Okay. I'll let you have that then. Okay.
Back to their normal position. Anyways, like and subscribe if you enjoyed the video. I really appreciate you sticking around till the end. And as always, hope you have a blessed rest of your day. Bye.
That was certainly a video. That was certainly a video that exists. Yeah. Of the April Fool videos that I've seen, this is probably one of the better ones that's out there. I think I need to up my game when I do an April Fool's video, to be honest.